Welcome to Station 4. This is 6.3 rotations. It's day 2 video notes. And I'm hoping that you guys this will be a good review refresher for you. So the first thing I want you to do is go ahead and take your notes and fill in the blanks. A rotation, just to reiterate, is a transformation that turns a figure around a given point. And the given point that we are going to work with is the origin. That's the point for our class we're going to work with. It's not the only point to rotate around, but for our class, that's what we're going to focus on. So that's our given point, but it's a rotation that turns a figure around a given point at a given angle. You guys, what that means, the given angle is that 90 degrees, 180 degrees, and 270 degrees and on. So those are the angles that we're talking about, clockwise or counterclockwise, whichever the case may be. So next section. A rotation creates a congruent figure. It's the same size and shape as the original figure. It's just in a new location. Okay? And then this is the chart that I really want you to pay attention to. All right, so we have a couple of things going on here. This is what I talked about in the video from the other day. A 90-degree clockwise would go from the top, and it would be a quarter of a turn to the right. But a 270 degrees counterclockwise would start at the top, and it would be a 3/4 of the way around to the left. But you would end up kind of in the same place. Like if this is your origin, you kind of end up in the same place. Okay? And so if that's, let's go ahead and go through these. 180-degree clockwise is halfway around, or counterclockwise is halfway around the other way. So you end up in the exact same place. Either way, when you go do 180 degrees, it doesn't matter whether you go clockwise or counterclockwise. 180 is 180. You're going to end up at the same place. A 270-degree clockwise starts at the top and goes 3/4 of the way around this way and ends up right here. And then a 90-degree counterclockwise starts at the top and goes 1/4 of the way around. But you end up at the same place as compared to the origin. And then a 360 clockwise is obviously all the way around, a full circle, and counterclockwise, same thing, full circle. Okay, so here are the kind of the rules that I want to rediscuss, and I want you to put these on your notes so that you have them. You don't have to refer back to your book. Okay, let's start with the 90-degree clockwise or 270-degree counterclockwise. You're going to honestly see the 90s more than anything. You're going to see 90 clockwise, 180, and 90 counterclockwise. Those are the ones you're going to see the most. You won't see 270 too often. You'll see it referred to as 90 either way or 180. So let's take the 90-degree clockwise. Here is our point from our original figure. So the ordered pair is XY from the original figure. And in this case, the example is 2 and 5. So we're going to do both. For a 90-degree clockwise rotation, we have the Y changing spots, the Y coordinate, whatever it might be, it becomes the X coordinate, so to speak. Our X coordinate becomes our Y coordinate, and it changes signs. So what that means is, just let me refresh your memory. What that means is, in this case, my Y coordinate is a 5. Okay? So my Y coordinate now goes to the X coordinate's place. So for my rotated point, this is now the X. I'm going to go 5 to the right or left. My X coordinate moves to the Y spot, the Y coordinate spot, and it changes signs. So since this is a positive 2, it becomes a negative 2. If this had been a negative 2, I would change this to a positive. So this right here just means change the sign of the X coordinate. Okay? It doesn't mean it is a negative number all the time. It just means if it was positive, it's now negative. If it was negative, it now is positive. Okay? So that would be how that would work. So for the 180-degree clockwise, what happens here is they stay in the same place. The X coordinate stays the X coordinate. The Y coordinate stays the Y coordinate. They just both change signs. So since my X is 2 and Y is 5, they stay there, but since they're both positive, they both become negative. Now I want you to understand, you guys, if these were both negative, they would become positive. This negative means the opposite of whatever they currently are in the original figure. Okay? So for the 270-degree clockwise or the 90-degree counterclockwise, we kind of do the same thing or something very similar to this over here. My y coordinate does become my x coordinate, but this time it changes signs. And my x coordinate moves to the y spot but stays the same sign. So they switch places, but this time only this one switches signs. So let's go back to this. My y coordinate in my original figure is a 5, or my original point is a 5. So my 5 becomes my x coordinate, and it changes signs. So my positive 5 becomes a negative 5. Again, if it was a negative 5, it would become a positive 5. Okay, my x coordinate becomes my y coordinate and keeps the same sign. Okay. All right, as far as a 360-degree clockwise or a 360-degree counterclockwise, we end up back in the exact same place, so nothing changes. Easiest one of the day. Ding, 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 that wins the prize. I like that one the best, but you won't see those very often. Okay, so moving on to the next page, we are going to do some practice at identifying which pattern it is that we are using. You have these on your page, but my original shapes here are x, 3, 4. My y coordinate is -1, 2, and my z coordinate is 0, -5. So that's my original triangle. Here is my rotated triangle, and let's look at how my points change. My 3 and my 4 are still a 3 and a 4, but now instead of a positive 3 and 4, they are both a negative 3 and 4. And my -1 and 2, still 1 and 2, but my -1 has become positive, and my positive 2 has become negative. So I'm kind of noticing that the pattern I'm seeing is that the x and the y are in the same place. They're just changing signs. So that's the pattern I'm noticing. 0 can't change signs because it's not positive or negative, it's just 0. But my -5 became a positive 5, and that works to this pattern. So go ahead and write down what you predict, which rotation it was. And hopefully this is the rotation that you picked, 180 clockwise or counter. It doesn't matter. For a 180, it's the same. So it's 180-degree clockwise or counterclockwise rotation. Okay, so that's what happened with these. So look at the next set of points. And let's look at the next set. We have triangle ABC, where triangle point A is -2, 6, B is 3, -3, and C is 4, -3. So now let's look at A prime, B prime, and C prime. So let's see how they've changed. So -2, 6 is now 6, 2. And 3, -3 is now -3, -3. And 4, -3 is now -3, -4. So I have noticed that, first of all, my y and x have changed places. So my y was a 6, but now that's my x. And my -2 was an x, and now it's a y. But which one has changed signs? The original y coordinate or the original x coordinate? Well, since my -2 is now positive, and my +3 is now negative, and my +4 is now negative, this one changed signs. So look back at your notes and see which pattern this is. Which one is y -x? And make a guess on what degree of rotation. Okay, hopefully you chose a 90-degree clockwise rotation, because that is exactly what happened. Okay, the y switched spots but did not switch signs. All right, let's look at the next one. I have quadrilateral JKLM with points -1, 5, 2, -6, 3, 5, and 3, -6. So let's look at the rotated points. I have -5, -1, 6, 2, -5, 3, and 6, 3. So if you notice, like the digits, 1, 5 is now 5, 1. 2, 6 is now 6, 2, 3, 5. So my digits, as you can tell, my digits have switched places, okay? But which one has actually changed signs? Did my x change signs? -1, -1, excuse me, 2, 2, 3, 3. My x did not change signs, but my y has. 5 became -5, My -6 became +6. So this is the one that has changed signs. And so predict which one that's going to be. Okay, so here's which one you should have put. 270-degree clockwise, or you may have written it like this, a 90-degree counterclockwise rotation. Okay. All right. I would definitely encourage you to save these notes. I know it's on the back of your homework quiz, but after I give you the homework quiz back, these are hole punched. I would save them because you would be allowed to use them on a future homework quiz or a future test like next week. And this kind of stuff will help you keep what you're doing straight.